Welcome back. So today we're going to be working on line drawing. And if you have the GitHub repo cloned, you should be able to follow along with me. We're going to pick this up right from where we left off last time and just put this thing together right now. So right now it's just rendering a PNG file to the screen, one pixel at a time. So we're going to start by clearing this out and then covering some of the really easy test cases for drawing a line. Close others, and we don't need this. So clear that out. And you know, I can't remember if I set up a clear function in... Nope, there is no clear function. Let's write a simple clear function first. Let's see. I have Code Whisperer running, so a lot of the simple stuff it's just doing for me. It's taken a while to... I don't know, I've been using Code Whisperer since last October, and it actually is feeling more useful the longer I use it. So, those things I recommend. It's free to use. I recommend just turning it on in Visual Studio Code and living with it and see how it feels. So we are going to start by commenting my own code. Hold on. Hazards of not working in TypeScript. I'm trying to be careful to at least define my types in the comments. Excuse me. Alright, so down here, clear. Let's clear it to, how about dark blue? Let's make sure I wrote that correctly. And we have our dark blue. And I think I'm going to disable the dev tools, at least on startup. I actually don't like seeing them every single time I start the program. That is done by commenting that. Make sure that worked. And there you go, no dev tools. You can still get to it through, I think it's toggle developer tools, Control Shift, it's an I? Yeah. We're going to leave that off. So let's draw a line. I'm actually a little surprised that it was able to just suggest something like that. It's wrong. I mean, it's not completely wrong. It is partially wrong. And, you know, let's go ahead and see if I can prove why it is partially wrong. Alright. Draw an arbitrary line across the screen. Okay, cool. Let's go ahead and use this to draw a couple of lines, and we'll see if the problem I'm thinking of will show itself. want to make this a little bit bigger. 256 by 224. So x1, y1, x2, let's say 203, y2, 174, and we'll make it yellow. Then let's see what that draws. Oh, well, there's the first problem. Those are the 2 points. It didn't actually draw anything. So there's the first problem, is that, yeah, I thought I'd draw more than that. X1, X2. That's actually super suspicious. I expected it to draw more than 2 points. The y value, see, that might be the correct formula for the slope. You know, mostly it's, I guess the lesson is don't just trust anything that Code Whisperer gives you. It does a lot for you, but it doesn't do everything. We're gonna handle this in 4 cases. First one, the really simple case. Wow. That actually looks closer to the right formula. But that's not how we're doing it today. So if the starting point is the same as the ending point, we're not drawing a line, we are drawing a pixel. So we're just going to draw that in return. Demonstrate that this works. So that should put a yellow dot a little bit further down the screen. You know, let's make this up. We're going to draw a red dot. And there it goes. You see a little red dot because the starting point is the same as the ending point, and that first line is not being drawn because if it can't draw a point right now, it's... And the second 2 cases, if x1 is the same as x2, but the y value is different, then we are drawing a vertical line. And this time Code Whisperer got it right. You're starting from the minimum, like y1 or y2, whichever one is lesser, and going to the greater of the 2, and then just setting a pixel for each one of those. So let's make sure we can draw vertical lines. Let's say 120 for x, y1, 110. For a vertical line, x has to be the same. I'm going to go down to 150, and we will make this one purple. And we test. Alright, there's our vertical line. And now the horizontal line is handled basically the same way. Let's see if Code Whisperer will do this one for us. And yeah, see, you can see in the grayed out text it's figured out basically what I'm aiming for. Let's run that test again. This time we will hold y constant at 110, let x go to 150, and keep the same color. I did something wrong. There's only the one line. Okay, let's go back and see what I did. It's actually not super clear. So log that in there. I didn't hold X constant. Okay, that makes sense. So the code was doing what it was supposed to do. If it was doing, well, obviously you can only do whatever you write it to do. And it's still not working. Okay, hold on. We'll keep that in there, going from the minimum of x1, x2, going to the max of those two. And then setting a pixel all along that line. This was if x's are not... Oh! This should actually be drawing another point. Check this out. If I change this to bright blue, you should see a point at the start of our vertical line. But it's not there, so, you know, I have me questioning everything now. Alright, we gotta do some debugging. Looks like our scaling function is sometimes causing pixels to not render correctly. That will be a shader problem, and we're going to have to address that at some point. I'm so curious about why that is doing nothing. The horizontal line will be drawn if the x's are not equal and the y's are equal. Let's go ahead and make sure. Let's see if we can get that working. The y's are equal, the x's are not. It is getting into that bit of the code. Need more details. Let's see. Let's see what that gives us. So it's setting all of these well, there's our line. Alright, we're going to have to work on that scaling problem sooner than I thought, because it looks like it's drawing the line, but it's just not visible in all cases, which is kind of obnoxious. Change the code a little bit and see if that gives us a different thing. There's the line. Why is it not always rendering. The pixels are chosen in the fragment shader here. The actual color comes from this. It looks at the texture, at the current, this is the actual sampler 2D reference to the texture that we're feeding it. This is that array of pixels positioned within the texture and returns a vector 4 for the color. Didn't disable this last time. That's the kind of thing that could get me in trouble. Let's go and rerun that, see if that changes anything. It has not changed anything. Trying the vertex shader. I haven't had to make any changes to this file in a long time. And what I'm going to do is basically disable all that math. That didn't change anything, and it really should have. Huh. Oh, there's 2 copies of those shaders floating around my code. That's probably why it wasn't working for me to demo the effects last time we spoke. Make sure we're looking at the right thing here. Does it still work? That's always the question. Okay, so that still doesn't work, but if I am referring to the correct file, making that change should change the appearance of this. Which it did. Okay, so basically that bit right there controls the texture coordinate, and what this math is doing is putting the origin where x equals 0 and y equals 0 in the top left of the screen. And so it makes sense that reverting that wouldn't give us anything useful. It's this next bit that should make a bigger difference. Well, it does. Now it doesn't render anything. So, ta-da! Unable to locate target screen size. Right, because WebGL has this annoying habit of, like, if you don't actually use these variables for some reason, then it clips it out of the compiled code. And then when your JavaScript tries to refer to that variable, it doesn't exist. Which is quite a bit maddening. Here. Let's see if we can cheat. going to use those variables and immediately undo what they were calculating. No, that didn't work. Alright, how are we going to do this? Target screen size and actual screen size. We're just going to have to go through and disable these. At least while we are debugging the problem. Okay. Alright, so disabling those locations. The effect of that is like it removes those black bars from the sides. So now the entire texture scales to what's going on the screen. And now we can't see the vertical line at all. Figure out what I am doing wrong there. That is making that not visible. Gonna run another experiment here. Draw a whole series of these horizontal lines. See if any of them show up. Oh, I got a fun error though. Oh, I know why. Need to turn this back on. Well, there you go. Draw a bunch of them, now you can see it. What I think is going on is some floating point numbers getting rounded off. Just gotta figure out how to make sure that doesn't happen when we don't want it to. You can see that red dot is disappearing sometimes too, due to a scaling factor that shouldn't be happening when we're stretching the screen vertically like this. Sure. Let me think. Just curious, I'm gonna turn these effects back on and see what change that makes. So we have three effects going. The curve remap is what puts the circular edge on the screen like you're looking at an old CRT. And then the bloom, you can see it's making the pixels glow just a little bit. and the vignette intensity is what causes it to fade out into the corners. So let's try some things. Oh, there it goes. You see, there's still a little bit of red there because of the bloom factor, even when the pixel itself is no longer being rendered. Why is the pixel not being rendered? I thought that this whole video was going to be on how to draw lines, but we might just let it be about getting these pixels rendered correctly. I'm going to reduce that back to one horizontal line. You can see with the bloom factor turned on, the invisible horizontal line is glowing just a little bit, which means it's being rendered, but that the pixel height is less than 1. Less than, like, this height of one virtual pixel is less than the height of one actual pixel. But why is that? Like this one function here, main, is called for every single real pixel on the display. And then based off of the position on the screen and the current texture coordinate, we have to decide what color to output in the outColor variable. We initially do that. I mean, the most important one here is getColor, which is just going back to the texture, looking at the position inside of that texture. And that function is wrong. Alright, WebGL. We need to, let's see. Try to figure out the right question to ask. It's a rounding error of some sort. Position, it's the x and y, but both values will always be between 0 and 1. We also know the target screen size. We need to make sure that this floating point value from 0 to 1 always falls on an actual pixel and doesn't fall between pixels. So, how are we going to do that? So that math will scale the x value up to an actual pixel, but it might still be between, like, to an actual virtual pixel, if that makes any sense. But it could still be between pixels, so we need to cast that to an integer. It looks like it might just be like that. And then I think we need to divide the target screen size back out. if that compiles, then it might work. It might get fussy about me dividing an integer by a floating point number. If it does, then we will fix it. Fragment shader is not compiled. Unable to locate target screen size. Well, that's because it didn't compile. I think the reason it didn't compile is because I have to do this. WebGL does not like mixing types. Oh, there's something. I'm going to turn off some of these special effects. We'll just take a second. The bloom was the most useful for diagnosing this problem. You know, that's actually really close. But now our red dot is gone. Oh. Well. Okay, where's the dot? Where's the line? Maximize the window, the line should still be there. Let's keep the bloom turned on until we figure out the rest of the problem. This should yield us a pixel value, an integer pixel value. And then dividing that back by the width will give us a number in the range of 0 to 1. That falls on an actual pixel. Just thinking. I think I'm going to turn this bit back off because I want to make sure there's no more weird math getting in our way. Turn all of it off. Yeah, I need to disable the actual screen size variable. The bloom is still turned on, which is why you can see that there. Yeah, that didn't help us at all. fact, it actually works a little bit better. It's like when I disabled that math, the line and that translucent dot disappeared completely. Trying to see at what point. There. Our dot's visible right there. And the screen is just about square. Let's go ahead and make this screen actually square. Still wants it to be shrunk just a little bit past the square. You can see with the black bars at the top and bottom. Turning the bloom back off. Some kind of effect going on that really feels like a rounding error. It just does. Sure, so. So how can we fix this? What happens if we turn that off? Well, it doesn't compile. All right. This is probably a bad idea, but we're going to try it anyway. Excuse me. Strangely enough, that did not change anything. Not really. Okay. I'm going to have to take this offline. I'll try to find a solution. And then we will continue in part 2. Hopefully with actual working pixels. And we'll pick up the rest of the line drawing function from there. So, see you next time.